Lesson 6.6, Scale Drawings. A scale drawing is a two-dimensional drawing that is similar to the object it represents. A scale model is a three-dimensional model that is similar to the object it represents. Remember, similar means the same size, same shape, not the same size. Scale is the relationship between the drawing or model's dimensions. And you can start here where it says relationship between the drawing or model's dimensions. We're going to watch a quick video on how we use scale drawings.
California is the third largest state in the U.S., so it's not surprising that it contains 4 of the nation's largest cities. If we were traveling along the coast, we might want to know how far our journey would be. We could measure the distance from one city to the next using a scale drawing, like a map. But how does the third largest state fit on the page of a map? For one thing, objects that exist in 3 dimensions are shown only from one perspective, like the mountains on this map. We see them only from above, so their height isn't evident. Also on a map, the sizes of all the objects or distances between places are changed by the same scale or ratio. On this map, 1 inch is equal to 80 miles. We can measure the distance of a trip in inches, then convert it to miles. Put that 2-dimensional calculation to the 3-dimensional drive test, and the mileage should be approximately the same. Let's road trip from San Diego to Los Angeles. On our map, the 2 cities are about 1.5 inches apart. That equals 80 miles plus another 40 miles, half of 80. In total, the distance between San Diego and LA is approximately 120 miles. Though you can only drive that distance in the 3-dimensional world, the 2-dimensional one should be proportional, and your mileage measurement should be roughly correct.
In example 1, use a scale drawing. On a map, the distance between 2 cities is 3 inches. What is the actual distance in miles between the 2 cities if the map scale is 1 inch to 125 miles? Let x represent the actual distance in miles between the 2 cities. The ratio of the map distance between the 2 cities to the actual distance x is equal to the scale of the map. What this is saying is that you need to write a proportion to solve the relationship. Here is the scale, so let's put the scale down as a fraction. Okay, so that's how it relates to each other, since that's what they gave me for the scale. Now, inches is the map distance, where miles is the actual distance. So 3 inches will go in the numerator of my other ratio, and x miles we do not know. Use cross products. 125 times 3 is 375. So the actual distance is 375 miles. Try number 1. On the map, the distance between 2 cities is 4 inches. What's the actual distance between the 2 cities if the scale is 1 inch per 80 miles? Set up the proportion and solve. Pause the video. You can tell that we need to put 4 inches in the numerator, because 4 inches is in the numerator of the scale. So we need to find the number of miles. Do your cross products. 320 miles is the actual distance. In example 2, finding the scale of a drawing. In a scale drawing, a wall is 2 inches long. The actual wall is 12 feet long. Find the scale of the drawing. Okay, this is 2 inches. The actual wall is 12 feet. Now again, what they have in common is that it's the measurements of the wall, whether it's in the scale drawing or the actual wall. This is called, you can say that this is a ratio of the wall lengths. So we can simplify this ratio so that the numerator is 1. Here's your ratio, 2 inches over 12 feet. Get the numerator to be 1. So I divide by 2 to get 1 inch. Because I divide by 2 in the numerator, divide by 2 in the denominator. 1 inch for every 6 feet. So the drawing scale is 1 inch to 6 feet. Again, the whole point is to get 1 in the numerator so that you can tell how many inches on the drawing is every 6 feet, or how many is every feet. In example 3, find a dimension of a scale model. A model of the Sears Tower in Chicago has a scale of 1 to 103. The height of the Sears Tower observation deck is about 412 meters. Find the height of the observation deck. Since we know the scale, we can set up a proportion. 1 over 103. And remember, 1 has to be the model. So we want to put the 412 in the denominator because that's the actual height of the observation deck. Do your cross products. Divide 412 by 103, x equals 4. So the height of the model's observation deck is 4 meters. Pause the video and try number 2. You are using the same scale, 1 from before, 1 over 103. Pause the video now. The height of one antenna is about 521.1 meters. Find the height of the antenna on the model. The height is 5.1 meters.